So this lesson is on radicals, and our objective is to be able to evaluate square roots and cube roots, and then also use square roots to solve quadratic equations. So here's the definition of a square root. I think you probably already know what this is. The square root of a is equal to a number b if b squared equals a. For example, the square root of 16 equals 4 because 4 squared equals 16. Is there another number whose square also equals 16? So another answer to what is the square root of 16? So 4 times 4 is 16, but a negative times a negative is also 16. So wouldn't it be true that negative 4 times negative 4 also equals 16? Therefore, another answer to the square root of 16 is negative 4. So it turns out there's always a positive and a negative solution to the square root of a positive number. Here's some notation stuff. This says the square root of a, and so that means the positive square root of a. So in this example, square root of 16 is 4. Negative square root of a denotes the negative square root of a. So in this example, that would be negative 4. So for example, square root of 16 equals 4. Negative square root of 16 equals negative 4. Because there are two solutions to the square root of a positive number, plus or minus square root of a denotes both of those. So for example, if we wrote plus or minus square root of 16, that would be positive 4 and negative 4, the two answers to what is the square root. So now let's do a few of these. Square root of 49. So what number squared equals 49? So that would be 7. And it's positive because there's no sign in front. This is negative square root of 49, so it's going to be negative, and what number squared equals 49? 7, so it's negative 7. So plus or minus the square root of 49 are the two answers, 7 and negative 7. Now let's look at square root of negative 49. So let's think. Is there any way to multiply a number by itself and get negative 49? Well, if we did negative 7 times positive 7, that equals negative 49. But those are not the same as each other, so that's not a square root. What if I did it the other way? 7 times negative 7? That does equal negative 49, but those are not the same number, so that's not a solution. What if I tried negative 7 times negative 7? Well, that gives me positive 49, so that's not a solution. So the answer is there is no, oops, sorry, that was supposed to be no. There is no real, because there are other numbers we don't know about yet, square root of a negative number. All right, now we're going to solve an equation. So we have x squared minus 81 equals 0. I'm going to solve it using inverse operations and by factoring. So inverse means the opposite of subtraction is addition, so I'm going to add 81 to both sides. So that gives me x squared equals 81. And then I will take the square root of both sides, because square root and x squared are inverse operations, so they cancel each other, and that leaves me with x is equal to, now I wrote square root of 81, but anytime you take the square root of a value squared, x squared, anytime you have the square root of x squared, you always get plus or minus the answer. So we're always going to get plus or minus. What number times itself equals 81? It's 9. So the solutions to this equation are 9 and negative 9. Now we're going to do the same thing a different way. So let's start over with the same equation. X squared minus 81 equals 0. And we're going to factor. So notice this is the difference of squares. If you really need to make the box to factor it, you can. But this would be x plus 9 times x minus 9. And then the zero product property says since they are equal to 0, then one of these must equal 0. So this gives me x equals negative 9, and this gives me x equals 9. So we got the same answers doing it two different ways. It's nice to have more than one method, because sometimes one method works and the other doesn't, and sometimes one of them's easier. Now let's solve a problem that's slightly more complicated. This one is definitely not going to factor. We've got a fraction, we've got a 7, they don't have common factors, so we're going to have to use inverse operations. So let's start by reverse order of operations. So I'm going to undo subtraction before multiplication and exponents, so add 7. So now I have 1/2 x squared equals 72. And now I'm going to multiply both sides by 2 because that's the inverse of multiplying by half is multiplying by 2. So multiply both sides by 2. So that gives me x squared is equal to 144. And now we're going to do the inverse of x squared, which is the square root of both sides. But anytime you take the square root of x squared, you always get plus or minus because there's two answers. So therefore x equals, what number squared equals 144? 12. So it's either 12 or negative 12, so two answers. All right, now we're going to move on to cube roots. So this is called the cube root of a, and it equals b if b cubed equals a. For example, what is the cube root of 64? Well, is it true? So let's check. What is 4 to the third power? Let's just check. 4 times 4 times 4. So 4 times 4 is 16, and 16 times 4 is 64. So what number to the third power gives me 64? It's 4. So the cube root of 64 is 4. Now, when we did square roots, we got plus or minus, but let's check if that's true for this. If I had done, let's check. It's not going to be true, but let's check. What if I did negative 4, and I said negative 4 times negative 4 times negative 4? I know the absolute value is going to be 64, but negative times negative is positive times negative is negative, so that is not a solution. So you only get the positive one with a cube root. So now let's do cube root of negative 27. So what number times itself 3 times give me 27? I know there's a bunch of 3's in there. So 3 times 3 times 3 is 27, but that would give me positive. So what if I make them all negative? Because it has to be the same number if I'm going to raise it to a power. Negative times negative negative is in fact negative, so negative 27. So the answer to this is negative 3. So notice we don't have the problem with cube roots where you can't find a real number who's for the cube root of a negative number. In fact, it does have a cube root. So that is pretty much it. So pause the video, do all of the guided practice problems, and then start it again and check your answer. So how did you do? I hope you did well.